Hey guys. So with energy that we've been talking about, endo and exothermic, and how heat moves in and out of systems and how that affects uh, the states of matter and their phase changes. We want to talk about how we measure energy. So we use energy, well, three different units. The first one we use, which is actually listed third, is the joule, which has the symbol of a J, which we've talked about. Remember, it's the international system, which is actually in some sort of Latin or Greek, and so it's like systematica, and I don't know, something. But it officially means the official unit of heat and energy. It's most common and is named after James Prescott Joule and is used all over the world. The unit we use to measure energy is the calorie. We see that most often with food, and this calorie has a lowercase letter c and is abbreviated as CAL, and is the amount of heat required to raise the temperature of 1 gram of pure water by 1 degree Celsius. Now there's another type of calorie, and this is a capital C calorie, which again the abbreviation is just going to be capital CAL, and it's equal to 1,000 small c calories, or 1 kilocalorie is another way that we say it. And this is 1 nutritional calorie. So if you look at a nutrition label on the back of a bag of Doritos or on a soda, you'll see that the amount of calories listed is with a capital C. And those are the 3 units we use to measure energy. And one thing that we talk about with energy and objects is an object's heat capacity. And so this symbol is a lowercase letter c. And when we talk about the heat capacity, we talk about the amount of heat needed to increase the temperature of an object by exactly 1 degree Celsius. And the key thing is that this is the entire object. And so it's going to depend on an object's mass and its material. So for example, if you have a bathtub and you have, let's see if I can draw a bathtub here pretty quickly. We'll have a clawfoot bathtub that's, got some water in it and some coming out of the shower. So if you have a bathtub, but you also have a tea mug, okay, and it's got some water in it, we know that the water in the teacup is a smaller amount, whereas the water in the bathtub is a much larger amount. So the bathtub is going to have a higher heat capacity. It can absorb the most amount of heat without changing its temperature. Another way of saying it is that you are going to need to put more energy into the water in order to heat up an entire bathtub full of water, which is why your parents say not to take long showers, because it's taking up a lot of energy, which is costing them a lot of money. Now, a formula we use for phase changes is what we're going to talk about next. So that formula is Q is equal to M times delta H. And this is what we talked about, how it's dependent on the mass. So the amount of energy required to melt ice depends on how much ice you have. And so remember, Q is the abbreviation for heat, and it's measured in joules. So if you see a number and it has a J after it or says joules, then you're talking about energy. And M is mass, and we use the units of grams to measure that. And our delta H is our change in enthalpy, and the units for delta H are joules per gram. So it's kind of a combination unit. And so remember, for delta H, you can use delta H of vaporization or delta H of fusion, depending on which one or what phase change is occurring. which you should look at your data table that we talked about in the phase change video and should already be in your notes to determine which one you need. Now, if we look at this first example problem, we see that the question asks us how much energy, so energy is Q, is required to completely melt 50 grams of ice. Well, that 50 grams is our mass, when the delta H of fusion is equal to 334 joules per gram. So when we solve these kind of calculations, we first want to write down the numbers that we have with their appropriate labels. So our mass is 50.0 grams. Our delta H of fusion is equal to 334 joules per gram. And Q is what we're looking for. We don't know how much energy or heat is required. We write down our formula that we're going to use, which is Q equals M times delta H of fusion, which it's easy to know which formula we're using because it tells us delta H. There's only one formula that we know of that has delta H in it, so it kind of gives that a little bit of an edge, and you'll be given the formulas on your tests and quizzes. You just need to know when to use them. So now we'll plug in the numbers we have. We do not know Q, so we're going to rewrite it. We know that mass is 50.0 grams, and we know that our delta H of fusion is 334 joules per gram. And the reason why I put these numbers in parentheses is to make sure that we keep our unit with the number that it goes with and that they don't get mixed up. So when these numbers are side by side, that means we're going to be multiplying. So this means that Q is going to be equal to 50.0 times 334, which is 16,700. And we can see that our grams are going to cancel out with grams. So grams will cancel out with grams. All that we'll be left with is joules, which is what we want to measure Q. So that means we're in pretty good shape, and that is the amount of heat required to melt 50 grams of ice, which is a lot of heat. And that is because water has a very high specific heat, which we will talk about in just a moment, but its heat capacity is quite large. Now, if we look at example number 2, it wants to know, is 5,000 joules enough energy? Okay, so they give us a amount of joules. And remember, when you go to the store, in order to determine how much, or if you have enough money to buy something, you look at how much that item is. You look at the money either in your wallet or in your bank account, and if the amount of money in your wallet or bank account is at least the same amount as the item that you want to buy, then you have enough. Or if you have more than what you need, that's even better. And so if we want to know if 5,000 joules is enough, we need to figure out how much is required. So we can go ahead and calculate for Q. So we have 10 grams of this liquid, so that's going to be our mass, and they tell us delta H of vaporization. So if I go ahead and calculate Q equals M times delta H of vaporization, that means Q is going to be equal to 10.0 grams times 2,260 joules per gram. And we'll be able to see that grams are going to cancel out. And when we multiply 10 times 2,260, we will get 22,600 joules. So that Q we just calculate, that's the amount that is required. So if we compare that to 5,000, saying, okay, is 5,000 joules enough energy to complete this vaporization? The answer is no. So we can say 5,000 joules is not enough because 22,600 joules is required. it's not even enough to complete half of the vaporization process. And so that is what we talk about with heat capacity and phase changes and how the mass of an object can impact the amount of energy or how we calculate. In the next video, we'll go through specific heat capacity and what it means and some example problems.